Welcome back to the deep dive. We have a really interesting technical guide on the desk today.
Hmm.
It's titled simply SQLite-Python.md. Now, I know that sounds a bit dry,
A little bit, yeah.
like the kind of manual you skim through at 2 in the morning when your server has already crashed and you're panicking.
We've all been there.
But when you actually sit down and read through this, it's not just a manual. It's essentially a treatise on how to bridge two completely different civilizations. You have the dynamic, flexible world of Python, and then the rigid, structured world of SQL.
It really is a clash of civilizations. I think that's what people usually miss. They think, well, I know Python and I know a bit of SQL, so I'll just, glue them together and hope for the best.
Yeah.
And that is exactly where the trouble starts.
That glue is exactly what we're analyzing today. We're looking at the standard library, SQLite 3, but specifically we're looking at the architecture of a healthy database interaction.
Yeah.
We're going to cover the right way to structure your files, the absolute nightmare of translating data types between these two, and the security implications that, if we're being honest, most tutorials just gloss over until it's way too late.
And that's the mission here, isn't it? It's moving from it works on my machine to this is production-ready code. Because the source material makes it clear the default way most people try to connect Python to a database is fundamentally flawed.
Let's start right there. The default way. I've done this. I think everyone who has learned Python has done this.
Oh, for sure.
You need data. So you write a script. At the top, you import SQLite 3, connect in the file, make a cursor, run your query. Then, I don't know, 5 lines later, you need more data, so you do it all over again.
The copy-paste anti-pattern, it's a rite of passage, unfortunately.
Guilty as charged. But the source material flags this immediately as a major structural flaw. Why is this such a big deal if it's just a small script? Why can't I just open the connection whenever I feel like it?
Well, think about what you're actually doing to the machine. Opening a connection isn't free. It involves file I/O, locking mechanisms, memory allocation. If you're scattering that logic all over your code...
Just copy-pasting those 3 lines.
Exactly.
Yeah.
You are creating a maintenance nightmare. What happens when you move the database file? Or what if you want to change the timeout settings? You have to hunt down every single connection string in your entire project.
So the source suggests a centralized approach. It points to a specific file in the repository structure called python-b.pyway.
Right. This is the utility pattern. You write the connection logic once and only once inside db.py. You create a function, maybe call it getDBConnection or just connect. And the rest of your application just calls that one function.
So it decouples how you connect from what you want to do.
Exactly. It decouples it from the actual work.
That seems obvious in hindsight, but it leads us to something in the file structure that I think trips up a lot of intermediate Python users.
I think I know where you're going with this.
The source mentions that this db.py file lives inside a folder called Python. But inside that folder, there's another file, an empty file.init.py.
The magic double underscore init.
It feels like a secret handshake.
Yeah.
The file is empty, it has 0 code in it, yet if you delete it, everything just breaks.
Yeah.
Walk me through what is actually happening when Python sees that file. Why does an empty text file change how the code runs?
It's all about namespace management. So when you just have a folder of scripts on your hard drive, Python just sees a folder. It's just a directory in the file system, nothing special.
Okay.
But as soon as you drop that init.py file inside, you are telling the Python interpreter, treat this directory as a packet.
Package being the technical keyword here.
Exactly. It transforms the folder into an importable module. So instead of just running a script in isolation, your main application can now say import python.db.
And without that init file.
Without it, Python looks at that import statement and effectively says, I have no idea what you're talking about. It lifts the velvet rope and lets the code inside that folder participate in the wider application ecosystem.
So it isn't just file organization, it's changing the visibility of the code itself.
That's a great way to put it.
It turns a collection of files into a unified toolset.
Precisely. And in the context of this source material, it is enforcing a structure. You have your main app, and then you have this Python package that handles all the plumbing.
Right.
It keeps your database logic quarantined from your business logic. It forces you to be organized even if you don't want to be.
Which brings us to the actual data. We've established the connection, we've organized our files into a package. Now we have to actually talk to the database.
Sure.
And this is where that clash of civilizations you mentioned earlier really happens.
The impedance mismatch. That's the formal term for it.
That is a great term. Because Python is this loose, friendly, come-as-you-are language You have a variable, it can be a string, then it can be an integer,
Hmm.
it doesn't care. SQL is not like that.
This is the strict librarian. It wants things in specific places, formatted in very specific ways. And SQLite, despite being light, is still a relational database. It has specific storage classes.
Yeah.
And the source material highlights a mapping table. And this is where a lot of those subtle bugs are born.
Let's walk through that map.
Yeah.
Some of it is pretty straightforward. A Python int is a SQLite integer. A float is a real or float. That's easy. We don't really need to dwell on that.
No, the numbers are the easy part. It's the text and the nothingness where people trip up.
Nothingness. You mean none versus NL?
Right. In Python, the absence of a value is the object, none. In SQL, it's the keyword NL. Now, the SQLite 3 library, it handles this translation for you automatically if you use it correctly.
If. It's a big if.
A very big if. Because where I see people fail, and the source alludes to this, is when they try to manually construct the query strings themselves. They might accidentally insert the string none, like N-O-N-E, instead of the SQL keyword NL.
And suddenly your database isn't empty. It's full of text that says none.
Exactly. And that wreaks havoc on your queries later because none is a value. It's a 4-letter word. NL is the absence of a value. Those are two completely different states of being in database logic.
Okay, then there is the issue of BLOM. The source mentions bytes in Python become BLOB in SQL. I always love that acronym. Binary large object.
It is a classic. This is for when you're storing things that aren't text or numbers, images, audio snippets, raw data streams. Python holds these as bytes. SQLite treats them as a blob of raw data. It doesn't try to interpret them. It just stores the bit stream.
But the real friction point, and the source material makes a specific note of this, is the syntax around strings. The quote clash.
Oh, the quote clash. This drives developers crazy, especially if they're coming from a purely Python background.
Python is so chill about quotes, isn't it? Single quotes, double quotes, triple quotes. It's all the same. Use whatever you like, just match them up.
But SQL's is not chill. SQL has opinions.
Not at all. The source specifies. SQL TXT values must be wrapped in single quotes.
And this is a part of the SQL standard that people often forget because, some databases are lenient. But strictly speaking, in SQL, single quotes like this denote a string literal, a piece of text.
Okay.
Double quotes like this denote an identifier, like a table name or a column name.
Wait, really? I want to make sure I get this right.
Yeah.
So if I write a query and say select from users where name land is Steve with double quotes.
The database engine looks at that and thinks, okay, I need to match the name column against another column that is literally called Steve. It won't see it as the text Steve.
That explains so many syntax errors I have seen in logs. Column not found. Steve. And you were sitting there thinking, I know Steve is in a column. Steve is the guy I'm looking for.
Exactly. So when you are writing Python code, which uses quotes to generate SQL code, which uses quotes, you end up in this Inception-style nesting doll of punctuation.
Yeah.
You have to wrap your SQL string in double quotes in Python so that inside it, you can use single quotes for the SQL text.
It is a syntax minefield. And honestly, this manual formatting of strings leads us directly into the darkest part of this deep dive. The part the source material warns us about in bold text.
The security imperative.
We have arrived at the core of the issue.
Wow.
We can't talk about databases without talking about injection. The source lays down a golden rule. Never use string formatting to dynamically create SQL statements from untrusted data.
And untrusted data means any input that comes from outside your code. A user typing in a box, an API call, a file upload. If you didn't write it, you cannot trust it.
Most people have heard of SQL injection.
Yeah.
It is the classic little Bobby Tables joke. But I think a lot of people don't understand the mechanics of it. Why is string formatting so dangerous? If I just take a user's name and plug it into a sentence using an F string, why does that break the database?
It is because databases are linguistic engines. They read the command, you send them like a sentence in a language. If you use string formatting like F strings in Python, you're constructing the sentence before you send it. You are literally just gluing words together.
Okay, so if I have a query that says, select user where name equals.
Yeah.
And I just paste in the input.
Right. If the input is just Alice, the sentence makes sense. Select user where name equals Alice. But if the input is Alice, drop table users, say, you've just sent the database 3 sentences.
Oh.
1, find Alice. 2, delete the users table. And 3, ignore the rest of the line.
And because I pasted it in using Python before sending it, The database just sees valid commands. It has no way of knowing that drop table was supposed to be a person's name.
Exactly. To the database, it just looks like you issued a delete command. You have handed the steering wheel to the passenger.
That is terrifying when you think about it.
Mm.
So the source gives us the solution. It is a single character, the question mark.
The humble placeholder. This brings us to parameterized queries.
I want to dig into the how here.
Yeah.
How does a simple question mark fix such a massive security vulnerability? What is happening under the hood?
It changes the order of operations entirely. When you use a question mark like select from users, where name, and you send that to the SQLite 3 library, something very different happens. The database receives the structure of the query first.
Just the template.
Just the template. It compiles it. It says, okay, I'm going to look for a name. I don't know what the name is yet, but I know that whatever comes next is data, not a command.
That is a crucial distinction. It effectively separates the code from the data.
It creates a firewall between content and structure. After the query is compiled and locked in, then you send the user's input to fill in the blank. Even if the user types drop table, the database just says, okay, I am looking for a user whose name is literally drop table. It neutralizes the code.
It is like checking a bag at the airport. The data goes in the cargo hold. It doesn't get to sit in the cockpit with the pilot.
That is a perfect analogy. The data cannot touch the controls. And this is why the source is so adamant about it. It isn't just a style choice. If you use F strings or string concatenation for SQL, you are bypassing this compilation step and leaving the cockpit door wide open.
Now, the source mentions two specific functions in the DB module to handle this.
Yep.
Execute and execute many. Execute seems straightforward, run one command. But execute many, this one caught my eye.
Execute many is a powerhouse.
The source says it takes a SQL template with the question marks and then a list of tuples.
Right, a list of data sets.
Why is this better than just looping? I mean, I could just write a Python for loop and call execute 100 times. I've done that before. It works. Why do I need a special function for it?
This goes back to what we discussed at the start about the cost of connections and transactions. Every time you call execute, there is a transactional overhead. The database has to listen, parse, run, and confirm. If you do that 1,000 times in a loop, you are paying that tax 1,000 times.
It is like buying groceries and paying for each apple separately.
Exactly. You walk out of the store, put the apple in your car, and walk back in for the next one. It is incredibly inefficient. Execute many is bulk processing. You say, here is the plan, and here's a truckload of data. Do it all.
So the database engine can optimize that into a single transaction.
Usually, yes. It opens a transaction, pours all the data in, and closes it. It is orders of magnitude faster. We are talking the difference between seconds and milliseconds, especially if you're inserting thousands of rows.
And it uses that same tuple structure we talked about.
Yes. You pass a list of tuples, and this is where that strictness comes back in. If your query has two question marks, say, one for name and one for age, every single tuple in your list must have exactly 2 items. Python and SQLite map them strictly by position. First item to the first question mark, second to the second.
It forces you to be organized. You can't just be sloppy with your data structures if you want that performance gain.
And that is really the underlying theme of this entire guide, isn't it?
It really is. We started by looking at db.py or organizing our code so we aren't repeating ourselves. Then we looked at the strictness of SQL types organizing our data so we don't crash the translation. And finally, parameterization organizing our queries so we don't get hacked.
None of this is advanced coding in the sense of being difficult algorithmically. You don't need a PhD to use a question mark, but it is professional coding. It's about discipline.
It is the difference between a script that works today and software that works next year.
Precisely. If you're just hacking together a music library script for yourself, sure, do whatever. But if you're building something that other people will use or something that touches the internet, these 3 pillars, structure, type safety, and security, are non-negotiable.
And I think that is the takeaway for everyone listening. You might think SQLite 3 is just a toy database because it is built in and single file. But if you treat it with the respect, you would give a massive enterprise database.
It will perform like one. It is incredibly capable if you respect the rules of the road.
Before we go, I want to leave you with a thought about that execute many concept. We often think of code as linear line by line, step by step. But execute many asks us to think in batches.
Vectorized thinking.
Right. Instead of whispering to the database one instruction at a time, consider, can you hand over the whole book at once? How much of your current code is walking in and out of the grocery store for a single apple?
That is a question worth debugging.
Thanks for diving in with us today.
Keep coding securely.